Applifting. It's great to see so many of you guys joining here today. My name is Tomáš Gerzičák. I'm Java tech leader here in Applifting, but I also dabble as a front developer, so you could say I'm a bit of a full stack here. So for those of you, who are attending for first time, let me give you a quick tour for our meeting space. So there's a beer, so you probably noticed. So what's the meetup without a beer, right? So then we have a food, so you probably noticed as well. Then the Prosecco and the toilets are in the behind. So yeah, it's labeled. Yeah. So now let's go for program today. We have 3 speakers. They're here. Each will be given 20 to 30 minutes presentation. And after each presentation, there's going to be a QA. So there's the Slido. You can ask questions there, or you can just raise a hand, and I will go to you with the microphone. So without further ado, I'm here to announce the first speaker, who is Lukáš Rychtecký here, and is going to tell you something about front architecture.
Are we ready? Okay. Good evening, all of you. It's good to see so many faces. So it seems that you are curious about the architecture, right? Okay, who I am? I'm just every Joe who is like programming for more than 15 years and bitching about your back code. Here we can see like I've covered almost all, mainstream languages, also non-mainstream languages. And I'm currently a solution architect at Applifting and also a counselor because like Applifting is being run by a board. So, do you know what is the architecture? What is the architecture of this building? Pretty modern, right? Does it look good? Maybe, right? Have you seen the nets? So, is the architecture good or bad? I don't know. So, the dictionary said that architecture is a style of building or buildings. Style, right? It's weird. So, it's just like how it looks like, or maybe also how it works, or both. But still, we are digital product creators, right? So, like how like my style of coding is related to the architecture of the product. Is there any relation? Well, the dictionary says that the software architecture is a set of patterns or structures. And the important thing is that there is a discipline in the architecture of creating and using these structures. That's an important fact. That's the style. That's the style how you design a system, right? Also, if you see like a project structure of your code base, and if you see through the modules that like there's a different structure, maybe the architecture is broken, maybe not. Maybe it's not same, and that's bad. Maybe it's not bad, because you just like change it to be better for some cases. Who knows? I don't. So who makes the architecture? Probably the architect, right? Architect is a person who design systems and put the structures together. So, like you have working code and your customer is happy, right? The important fact is like there's a designing process. And designing is not that you just sit in front of your computer and like playing with ChatGPT and like creating a bunch of code. That's not designing process. The design means thinking and sketching and throwing away your ideas and maybe creating some, a proof of concepts. That could be together with ChatGPT, and that's totally fine. So why do we even care about the architecture? Why can just we sit in front of our computers and just write a program as like our customer says, okay, I need this kind of functionality, so I just sit down, write a code, and it's done. Why don't we like work like this? Or maybe some of you or us work like this. Maintenance? Okay, who cares? Like, customer is going to pay me anyway, right? And like the code would be rebuilt it in next year anyway, because there would be new front-end framework. So, is it that way? Nope. Because our goal or responsibility is to find a solution for some criteria or requirements of a customer. And engineers or developers tend to like looking disrespectful for the architects and saying, okay, this guy just like creating some UML diagrams in enterprise architecture, and these diagrams are totally unrelated to the problem and to the code base. So these guys are weird and just like writing something on a paper, but this is the real job, right? You're smiling. So, like, is it true? So, what's the goal of the architecture? I said that we want to, meet the requirements and the expectations. But the goal is that we are trusted by the customer, right? We are professionals. Customer has got a problem, right? And we are professionals who offering us solutions. The important fact that we are offering solutions, not the code. That's like one of these solutions could be producing code. One of the solutions could be not producing any code, maybe deleting the code. Yeah, right? Yeah, but the fact is that we need to find a solution by considering all these things: time, scope, budget. So it's just like play with the trade-offs. Every time is a playing with trade-offs. You want high performance? Okay, it's probably that there will be like tight coupling between some components. So your development speed will be much slower, but the system will be faster. You may say, okay, I can design a system that could be fast and also being designed to be like very easy and like organizedly, maintained and so on. Yeah, that's true, but there will be probably other trade-offs because there are more things like this. Does anyone know what's the difference between hardware and software? Any idea? What is it? Yeah. What's the difference between hardware and software? Nope, that's not the difference. Yeah, like it's actually different, but not in the sense of in computer science. So we are software developers, and you have no idea what's the difference between software and hardware? Okay, you can touch it, but like I can print my code and touch it anyway. No. The point is that software should be easy to change. It's in its name. It's software. It's easy to change. Because when you create some hardware, you cannot change it easily, right? You need to change the physical structure of it. And probably it's much harder to change the molecules and atoms rather than like changing some line of code. Sometimes it don't. Right? How many of you experience a situation when a product owner came to your office and say, okay, I need you change this and this. Like this is small change. I just need like customer's name in his, like receipt or something for an order, for example. And you say, okay, it would be 20 man days. Is it a real case or not? Like, and why? Why it's 20 man days? It should be easy, right? Why it's not easy? Because your colleague told you, don't do over-engineering. You can just like using the plain structure and put a bunch of code, just make your job done, and that's it. Don't overthinking. So when we stop thinking, we are not thinking at all, not overthinking, right? I really like to keep it stupid simple statement. Because it means like to think first and like make it in the next step, right? Or make your task done in the next step. But you need to think in the first step, right? Not just like blindly sit down and like writing down the data structures that are, for example, in the requirements or wireframes or something. Yeah, KISS is a trap. Because it's like it leads us to the stage when we say, okay, I got a user entity in my database. I'm just like getting a user by the ID. Okay, I need to send a mail. So, okay, I can just use the structure as it is, creating new service or maybe adding a new field and just like, sending the mail, and it's totally fine. So you end up that having like send welcome mail method on your user entity, for example, okay. And because like it's simple, right? You just like need the user, load from the database and send a mail. It's simple. It's simple, right? It could be like done real fast, few lines of code. What's wrong with this design? It's a trap in a way that like maybe the design is poor because we didn't take time for thinking about the future and checking all of these requirements. Because the architecture has got some requirements. Not only we need to send a mail to the customer when like X and Y happens. There are other requirements. Performance, speed of delivery. Yeah, or downtimes or something like this. Or you just blindly follow the frameworks and tutorials, right? Because okay, I'm working in Spring, okay, I open the Spring tutorial, okay, I get my user service, I put just a bunch of code there, okay, I'm just mocking my repository and it's totally fine, right? Because it's like in the tutorial, and tutorials are being written by the professionals, and these professionals has written the Spring core code, so these are the super guy, right? I didn't saying that like Spring tutorials are wrong or something. I'm just saying like you should be critically thinking about it before you just like blindly writing down your code. So if we don't over-engineer our code and we don't even think about our code, maybe we under-engineering our code. So we are locked, for example, in frameworks, like way of doing things, because like everybody is doing like this. I spent 20 years in a bank. Don't tell me how should I structure my code. We've been doing this kind of way of all the time. I heard all these like statements, like last 15 years. And the very beginning of my career, I thought, okay, I'm stupid guy with being junior without any experience. But after 15 years, I still don't understand how these people could work. Now I understand why they spent like 20 days doing simple tasks. Because there isn't no one who has been thinking before how to structure the code or maybe design the system before that. So what should I do right now? Like everything is bad, everything is good? No, it's not like this, right? I would say just like start asking questions. That's the important thing. Are you designing a system for, a year or 20 years? There is a difference. Are you doing prototype? The way of like creating prototype would be maybe not, very different than creating system for 20 years. And I hear you. I hear you are saying, okay, I 5 times created a prototype, and now this prototype is in production, right? Yeah, but that's totally fine. It's a trade-off. And you should offer the solutions, and the customer or maybe product owner or stakeholder should decide. But the thing is that we probably don't communicate all of these trade-offs. And the fourth point is very important. I like see it almost every time that like developers do almost all their decisions like unintentionally. Because okay, I see this pattern 20 times, I'm just doing my job. No, you should like intentionally design the system and communicate these intentions in a team. Which means, for example, sit down, write a document that could be like a few lines of code that like, okay, we were thinking about like how to make like this working. For example, you are having a system and a stakeholder comes to you and say, okay, we are thinking about a multi-tenancy. How many mandates do you need? I say, I don't know. I can come up with 3 solutions, some soft tenant, hard tenant, and so on. Write down all these pros and cons and make him or her to decide. It's not my job. My job is to just make all these like, things explicit and write down these. Because like if after a few years, product going to say, okay, we are so slow to the market, I can say, okay, we made this decision. It's there. We decided to being slow for other reasons. When we talk about architecture, like almost every time I heard a magic word Kafka or Redis. Is it an architecture-related thing? Yes? No? Well, the correct answer, it depends, right? As every time. Because we have more like views on the architecture. We have application architecture. That's how we model all our requirements and functionalities. And that's mostly just the plain code base, plain classes, functions, interfaces, and so on. And there should be no specific technology included. We have infrastructure architecture. Because if I'm speaking with my colleagues from the cloud department, and when they talk about architecture, they are talking about how these things are, being like set up on Kubernetes or something like this. What is wired to what, the Kafka is wired to these services and so on. What is running on high availability mode and so on. And there's the architecture. It's still the architecture, but it's a different view on the architecture. So when someone tells you, okay, our project is like using, Kotlin, new fancy language and Spring, and we are having Kafka for the messaging stuff. Okay, you just told me about your like technology that you use, but I have no idea what your like project like does, right? It doesn't even imply that the project or system is fast or something like this. There's no implication. You're just saying, okay, my wheels are from the Goodyear company. Okay, good for you. And there should be probably an architecture decision record that addressing, okay, we should Kafka for these reasons. I really love Kafka. No, I'm just kidding. And I have nothing against Kafka, but I many times say, okay, let's use Kafka because we need messaging and so on. And my favorite question is, okay, have you spoken with your CFO about the Kafka? Because like when you have like bigger system, there would be 10 or 15 programmers, right? So you would probably have like four environments. Okay, so multiply with the managed Kafka, and CFO would be here in a minute with the bill. So maybe there's another solution. And that's our job. Write down, okay, we need them like messaging. Okay, there are these 2 possibilities. There are pros and cons, and also the price. Not just blindly saying, okay, I want to use Kafka because it's so fancy. So, if I would like tell you a few advices, just ask a lot of questions. That's an important thing, because without asking questions and being critical, you cannot fully, or not fully, like you cannot understand like customer's domain or needs on a good level. Because otherwise your advices could be like so cheap, right? Okay, we can use like Django and put it together with like Postgres, it's totally fine. Okay, maybe it's not because I'm just like designing system for, you know, for like next 2 months and I want to throw it away. So we can do it in maybe some local platforms of like this. I don't know, it totally depends, and that's the important thing. There is like no right answer in the architecture. You should be focusing on solving customers' problem, not just playing with some fancy tools because you are unmatured. If you want to play with Kafka or something like this, and you have a project for it, just like create your side project and simulate the traffic or something like this. I know this is hard to do it, but it's much more responsible than playing with customers' budget, right? My favorite one, postponing all the decisions. When I started my career, I wanted to be an architect because I thought, okay, I would be the guy who is choosing the language and the frameworks and how we name the entities and so on. That would be super, super great. How wrong was I? By postponing decisions, you're like your solution space, you are like pushing forward your solution space. Because like every decisions make it smaller. Or, yeah, smaller because you need more money, which means smaller, right? And the final one, architecture decisions records. Write down all your, decisions. Ideally, you decide, or you consult the decisions with your team or something like this. Also, if you pick up something for how we are gonna name our, naming convention for your database schema or tables, just write down and document it saying, okay, we are using plural forms, and that's it. It's totally fine. No one could come and start bitching about like something is wrong, because it's like explicit. So you onboard a new teammate and like, okay, there are decisions, just read it. There would be few files. And it could be a repository with your markdown files, and it's totally fine. Yeah, and that's it. Do you have any questions?
There's still no question on Slido,
No
so
questions.
if you have some question, please raise a hand and we're gonna come to you.
I'm sorry that I bored you.
Huh?
I'm just joking.
Okay, so maybe I would have some question about. Oh yeah. Go first. Yeah. Yeah, me. Okay, so I think at the beginning of the presentation you mentioned keeping of the consistency of the whole project. So maybe my question is that should the architect be present at the like normal day-to-day processes of like checking the code, probably like checking some consistency between this, because I know like in some bigger projects maybe you should outsource it to like senior developers or something like this, or creating some guides, but maybe like some of us you want to know that how is this process gonna like what's the good practice about keeping the consistency of the big projects?
Yeah, very good question. I like it. Okay, in ideal world, your architect would be like on daily basis on your project. And like the issue with this, that is like your budget is usually pretty limited, so your customer cannot afford that. So like my advice would be like having the implementation team or build team, during the design phase before like you start implementing something, so they understand your decision. That's the one thing. Making all these decisions explicit and reasoning why and so on, and put it in the repository with, for example, if the documentation could be Confluence or something like this. And because the architect could not be here on daily basis, I would go with like senior guy who is responsible that all the daily decisions, the implementation decisions would be aligned with the architecture, and if not, and you need something like advice or some discussion on changes like the architecture changes, just like sit down and having a meeting with your architect or something like this. That's what I would do. But it's like you heard there are few trade-offs, right? Because the architect is not daily on the project, so it could happen that like after like month without a project, you don't have the project in your brain because like context is being flushed, right, and so on. So like it's a trade-off. And did I answer your question?
Oh yeah, thanks.
Okay.
So like if you need to recap it, so you mean like writing good documentation about the whole processes and clearly communicate the whole stuff.
That's an important thing. Clearly communicate all your intentions and so on.
Yeah, sounds good. Thanks. So,
Okay, so what do you think should be the outcome of a architect? You partially, what should be the outcome? You partially answer it right now, but the complete answer.
I know that like Scott Blushin would not be agree with me, but I would say also the diagrams, right? At least the for me it's like a high level architecture, so could be like solution architecture. What technology do you use? For example, another thing would be like the application architecture, how you are gonna structure your modules and what kind of modules are there and how they interact together, if they are decoupled or if there's some messaging or something like this.
So the design patterns as well?
Yes, but for, let's say, important part of the project. Yeah, let's say, for example, I have something on my mind. You have project and you know that like there is an entity that would be polymorphic, that would be like 50 or 60 ways of like implementation of these. Yeah. So you want to having this entity in the database, there's some application logic and also some UI part that would be rendered. So, do you see that you have your entity that's on the back end, right? And also rendering that's on front end. So you would end up with having like, let's say, at least two functions or two structures or stuff like this. But you can still make the system being like extensible without any dirty switches or something like this, or if else. Yeah, so you can use something like something like factory patterns and so on, and put them together. And that's what I would document. But there would be other details that are not important to document because, or what I would do is to create, let's say, skeleton of the module. That's how we design the facade of the module. And there is a naming convention for something. So everyone would be sticking this. And this could change in future. It's called evolution architecture. Is totally fine to do it, but it should be intention, not something that, okay, I decided to change it, so I just change in the code. Not following, the way how it's done. Because these inconsistencies could be much worse than, like, let's say, different naming or formatting of the code. And there's the outcome. Yeah, and like, also, I would say there should be like something like being called project dictionary or domain dictionary. It's like in domain-driven design it's being called ubiquitous language, which means like same words that you use, you as a developer or architect, and the business, and say words that being used or terms by product people and so on. So just simply table, the term, and the description, what is it, and not using synonyms or stuff like this. Because I experienced that these things lead to mistakes, unwanted, because, okay, I just like updated the transaction as you wanted, but I was talking about this kind of transaction. That's not transaction, that's order, but we name it transaction, and so on. Been there, done that.
Me too. Okay, thanks.
Any more questions?
Yeah.
Yeah, it's more of a general question. You showed different types of architects. I'm from infrastructure side.
Yeah.
But generally, I get a question about like what is the difference between application architect and solution architect, how they work together, brainstorm and come to a solution. So there is also, in each company they have an architecture board, right? So sometimes application architect takes decision and sometimes solution architects take a decision. So it's a bit, I'm just trying to understand the roles and responsibility of these two.
Yeah, okay. I'm not the only one who thinks that the application architecture should be totally agnostic of the infrastructure. That's the first thing. Infrastructure is not just the Kubernetes or AWS and something like this. It's also that I use Spring for dependency injection. But the point is that that's infrastructure detail being used on application level. So that could sound weird, right? But the thing is that like the application architecture or the application code should be like agnostic totally to the database, frameworks, and so on, right? So if the code would be written in Java, it doesn't matter if it's being run on Spring or let's say on Swing UI on my desktop or something like this, because I can take the code and just like inject all these implementation details that could use the the infrastructure. That could be like a relation database or something like this. But I'm not sure if I'm answering your question.
Partially. So what the solution architect will do in general?
Yeah, and like the thing is that like when I see like almost every time when I see some like some proposals for the customers and so on, and developer or architects talk about architecture, they mean solution architecture. So because they mix all of these things, because they say, okay, we were using Kafka managed, there would be Spring application, maybe there would be some modules, but not talking about if they are decoupled or not, because developers tend to use term modules for just like file, but that could be like tightly coupled files together, right? It's not a module. The definition of module means that it's separated piece of logic or set of the logic that is highly like decoupled from the others. That's the definition of module. So there's the thing, and there would be like probably some VPN, and you would also include some third-party systems that you call in this diagram. That's usually almost like every time what I see being called architecture, but that's for me the solution architecture, because you highlight your implementation details and the technologies. And these are also important because let's say that your non-functional requirements would be speed or something like this, so there could be decision using MySQL versus Postgre, or let's say that we are working with some geodata, right? So I would be probably using Postgre with some plugins, because it will be super fast to do it on like database level, not to take it to the application code and do it here. Probably, I don't know, I'm just like, so it's like mixture of everything, but this does not help how engineers should like implement the application architecture. Sorry.
Thank you.
Yeah. So go ahead.
It's just comment for this question. From my point of view, solution architect is architect facing to customers, and application architect is architect facing to developers. So solution architect, we have has this kind of task. We have our platform, we have our capabilities, we have those integrations, and how we will solve your problem with those things. Application architect is about how we will write application to be maintainable and so on. Make sense?
Yeah, totally. Thank you. Thank you for the definition. Go ahead.
Question, how often your customers wanted to guide you or tell you which infrastructure to use, or to confirm your infrastructure, or if they have some requirements?
The answer is it depends, right, on so many things. But like, let's say that you are working for, I would say corporate, which, like, it's not like negative term. It means like it's like a huge company, and they probably got a portfolio of their services and get the IT department, and they probably using, for example, AWS. So they obviously want that the new system would be running on AWS because, you know, of the contracts and maintenance and so on. But sometimes they also include, okay, it needs to be implemented in 3 languages or 2. You choose one, and like using the Postgre is fine. But if we would be using Rabbit or Kafka, it doesn't matter most of the time. That's like one typical case. The other case is we don't care, just like have a job done, right? And like the third case is we are cloud agnostic. We have our own, like, you know, servers and so on. But they want to include also the billing strategy or the, you know, the billing costs or expected costs in the offer. So you take the 3 main, let's say, cloud providers and include also the local providers. That could be, you know, the Česká radiokomunikace, for example. Because like it matters. Because if they are expecting to, you know, having some, you know, some number of their customers in the future, so you can easily multiply like these expected costs and see, okay, it maybe would not be like fast enough at the very beginning, let's say in 6 months, but we expect to having, you know, like 1 million transactions per month in 2 years. So it would be better to go on local cloud provider than go to the, like the, you know, hyperscalers as the free one. So that's how it's being done.
So it's common.
Yeah, very common.
Okay, somebody?
So I would just like to ask, what would be the decision point for you when deciding the architecture? For example, you get a startup coming to you, and usually you don't get the final picture, what they want, right? You usually get some MVP, and like you mentioned, you're gonna build this tightly coupled or loosely coupled. And then you can imagine there is some point at a time, you get to point, you realize you just need to split to microservices or stuff like that. So what's the decision point for you to say, we go tightly coupled, all like done like in a week, or you need to take more time because, and what's the kind of arguments with the customer there, because it's gonna cost more money, and yeah, basically.
My very favorite question, I like it. My like general strategy, like it depends on what you need. And for example, I have just currently one project where a customer said, okay, we are not sure what we are going to build because it's like in ESG segment and this is like pretty new environment, right? So we decided to go with like classic MVC monolithic like framework because they need to be fast on iterations and changing the product really rapidly. And even if we are expecting there will be some tight coupling, but we don't know what we are going to build, you know, as you said. So that's the reason why we decided to go with Django, for example. It's the real case. Next case is the like on the other side. Our customer that like we are designing system that should be here for more than 10 years. They got established business. So they know their customers, and then they know what they are going to build. So we need to think like forward, and like designing the system being, you know, decoupled and so on. And we also need to include the costs of like for the SLAs and cost for the infrastructure, obviously. And so like this, like the Django approach would be much faster on the very beginning, but in the long term could be like slower. But we are not sure what we are going to build, and it's possible that after 2 months we throw it away, the product. On the second case, as I named, the product would be here for years, because they know the market and like they got the experience with the customers and other competitors. So that's what I'm asking, what we are going to build, and that's what I also clearly communicate to the team. Hey guys, we are building system that should be here for more than 10 years. So like that's like that, I would say that it's different level of care, let's say. It doesn't mean that you don't write tests or something like this in the first case, but it means that you are designing system that should be easy to change and evolve in the future without any, slowdowns or without any, any these kind of issues. And it happens that you realize, okay, we designed that these two services or like domains separated, but they should be like merged together. Yeah, it happens. It's like it's normal. Yeah, but what I would be really careful not to starting new project in microservices. Yeah. Even if like the project would be like 10 developers from the day one, I would start with like decoupled modules or components in a monolithic deployment. And if this would be pain after a month, it would be still easy to come up with the microservices. Then like starting with microservices, because like the cost for them, like almost every change is like super huge. And like I know many startups that being killed because of this. And also the thing that I didn't mention is that I would also really let's say careful when like going full let's say full cloud. So using all these like lambdas and everything and Firebase direct on a cloud provider, because you tightly couple your system to the cloud provider, so you have probably high speed of the delivery very beginning, but in the midterm, it would be super slow because you, for example, cannot run all the software or product at once because all your logic is being not decoupled. It's like it's a distributed. You end up with a distributed monolith, and like your business logic would be like, let's say, split into some handlers and lambdas and so on. So it's hard to debug and evolve this kind of system. So a system that is like highly available probably, but adding small feature is super pain.
Okay, thank you.
Okay, thank you for all your questions. I'm afraid that we don't have any time for another questions, but Lukáš is gonna be here, so you can ask them.
Yeah, okay. Like you can.
Yeah, I'm sorry, we don't.
No,
Yeah. But you can ask him later. It's gonna be okay. So right now, I would give like 5 minutes break, and then we're gonna have to another speaker.
Thank you. Jsem si to rozehřál trošku.
Hello, sorry, we're gonna start in like 1 or 2 minutes, so if you can please sit down and calm. Yeah, thank you. Okay, hello again. I'm here to present our second speaker, Provazník. So please welcome him, and he's gonna tell us something more.
One, two, 1, 2. Yes, now it's working. Hello, can you hear me? Yeah. I'm really sorry. The reason I'm here today is to make it way more easier to my other co-speakers because I'm going to lower down your expectation about the technical topics. I need to really apologize for my voice because, as you probably some of you know, I'm a big fan of hockey, and what happened on Sunday really took my voice off. So Pastrňák scored really too late for me. Anyway, today I will talk about how I'm used to approach complex domains, what I learned from my years in IT, and this time it will be for you sort of like a mixture of from, let's say, application architect level, and also from the other aspects. You will see by yourself. As I said, I'm here only to entertain you with the bad content, so don't worry. My name is Provazník. I'm working in a company called Ciklum Western Europe, also previously known as CN Group. I'm a lot into functional programming and especially F#. Unfortunately, in latest days, I'm not really coding too much anymore, but still somehow I'm trying to get my hands dirty with code. I'm occasional speaker, F# evangelist, and I'm also doing podcasts because I don't know if you're aware of it, but it's now sort of like requirement in IT that you either need to have a podcast or newsletter. So we decided to go with the podcast. It's called Provazník, which is only funny in Czech, so I will not translate it. And you can see there's like more than 50 episodes. I hope you will find it interesting. Give it a try. Today I want to talk about complexity in architecture and in software in writing code. But before we start to talk about complexity, I would like to talk about software development as such, because there's one thing we need to understand and we need to realize is that the reason why we are writing code is just to automate, simplify, speed up, whatever you call it, already existing process. We are not really inventing anything. Usually, nobody is paying us for having fun while writing code. It's good to have fun if you're writing code, cool. But in most of cases, we are not the inventors of anything new. We just take paperwork processes that exist in real world and move it into IT, which is great, which is fun. But we need to realize that in software and in writing code, we are here to not to write code, but to solve business problem by writing code. I would even say that if you end up in writing new code as a solution to the problem, you probably failed in finding any new, probably cheaper solution, because writing code, thanks to our salaries, is quite expensive. And so think about it, and also think about how we all the time failing in not creating an additional unnecessary complexity while doing that. And why for me this is important, and for you should be as well, is if you think about it, look back to your history, writing code, all the solutions you work on, usually it's said that you spend 10 times more time just reading code than writing. So any new code you write is actually like backdoor from complexity. And I used to work in big company as a C# developer at the time. And when I joined the project, I literally like broke my mouse scroll. So I was reading so much code. So really like the reading is most of the time what you will be doing when you're coding. So think about it when you write something new, because it will live with you forever. And normally it's said that around 70–80% of your time you just spent in maintaining that code that you write before, and rather than creating a new one. So what I'm trying to say is that the complexity that you are going to introduce in your architecture, in your code base, will live with you way longer than ever imagined. So be careful, and I would like to tell you some quick, not wins, but tips, how to tackle the complexity. First thing, complexity. If you go do what I did, you go to ChatGPT, of course, and you ask about complexity, you end up with different kind of point of views on complexity, like code, system, project, data, network, architecture, whatever. Today, I'd like to focus on two things which are sort of like related, which is code complexity, which is like degree to which you understand the computer program source, how it's difficult to understand, maintain, modify, extend, whatever. And cognitive complexity, which is like your mental effort required to even like understand those things within larger code base, which is influenced by many more factors. One thing, speaking about complexity as such, is there are like two types. First one is natural, and it's absolutely okay to have it. It's thing that natural complexity cannot be avoided. Don't be afraid. It will be there forever, because some domains, some programs, some business problems you are trying to solve are just naturally complex, and there's nothing you can do about it. Second thing is that natural complexity is omnipresent. It's not that only you as a software developers, you poor guys, you need to tackle it, and everybody else is living really happy life. Nothing like that. I think if you jump to the different job and do different stuff, you will end up with nearly the same problems as you do as a software developer. So really, like, complexity is everywhere, and I would say it's like essential part of fact that world by definition is difficult place to live in, and it's complex, so it's normal. And usually, and I also see this in the latest months, also from different perspective, not only from like coder, but also from, let's say, when we are talking about how companies are built and how teams are built within the companies, that the higher importance of the process you are trying to somehow understand, the higher the complexity, because there are more stakeholders, different views, and God forbid if there's someone from law and say, okay, by regulations you can't do it like that. So don't be afraid. Natural complexity is here with you, will be forever. This is not the problem. This is just as it is. The problem is things that we do to ourselves, and I've been doing it a lot of times, so I'll be like shooting my leg right now and telling you my terrible stories, is adding things that are not providing any benefits, or if they do, it's not proportional. So you are having a lot of problems, actually it's the opposite of benefit what it provides, the unnecessary complexity. It's increased the potential for bugs, for longer maintenance, it's costly. This is your, I would say, number one enemy in software development, in architecture, in whatever you do regarding the IT. This is what you should think of as like, okay, I want to get rid of it. Ideally, you will have some, you always have some unnecessary complexity, but your goal as a developer and architect is to keep this terrible animal as the lowest level possible, ideally none, but I would say none is not even possible. I was thinking a lot during my whole career, like what I was doing wrongly. Like what's the main reason for this unnecessary complexity? And if I will be frank to myself, I realized that the reason number one is the Gaussian distribution, is that we work in IT, so we are well paid, we are creating smart solutions, oh God, we are so mighty, we are building this amazing stuff, we must be there, right? We're geniuses. I don't believe so. I think most of us, I would say by definition, we are, of course, like we are probably not here, we are somewhere there, but still, we are not geniuses most of the times. We are normal human beings with flaws, with sometimes box thinking, with many, many problems. And even, like I would say, we are smart, we are not that smart. So I would say that our goal is not to get to the top 5%, like good luck trying that. I just, like, I gave up. Yeah, like, I'm here, I'm happy there, right? But you can try, definitely, be my guest. But my goal, personally, was to, okay, I'm realizing I'm not there, probably not there yet, or not there never, it's okay. But you just need to, like, know it, that, okay, I'm not that smart, and I will approach the problems with this point of view. Because when you start with the symptoms of complexity because of I was way smarter than I expected, is that, first of all, it was already mentioned, the over-engineering. Like, let's add something smart, right? I personally, and Jirka is here today, I can tell you how I reinvented the F-sharp pipe operator, because, God, I'm now into operators. So I add more and more and more, and one day he said, come on, guy, you're crazy, you just reinvented the pipe operator. It's been there forever, you're an idiot. So over-engineering, it's the first symptom. Second thing is, let's build our own framework, because there's still 1,000 buttons left, and let's add another one, right? Like, this is related to over-engineering clearly, but again, we are thinking we are so smart, so we will create something which will like solve all the problems, and right, yes, let's do it. Premature abstractions. I need to say I'm really happy that I'm second here, because I think you will see 3 different point of views on the stuff, because I will sometimes contradict to what Lukáš said, and definitely also contradict to what's expecting like next. But I would say it's my favorite one. It's premature abstractions. I saw this piece of code twice. Let's put it together and give it the same behavior and make it a generic, and now we won. Nothing like that. Unnecessary scalability. That's also a really funny one. When, of course, I have blog, my mom's reading my blogs, so let's put it into Kubernetes and run it on AKS. Why not? And also wild inheritance, excessive dependencies. Let's make everything depending on my custom written libraries. I don't need 99 out of 100, but like it handles most of my cases, right? So, how to tackle this problem, except that realizing that I'm not so smart yet? I think there are 2 things in my life that helped me. First one is DDD, which stands for Domain-Driven Design, which stands for software development approach that emphasizes collaboration between the technical people and experts write correct code that accurately models the business domain without any more ideas, just follow the business. Second thing is STFULLTC, which means that shut the fuck up and listen what customer is saying, which is software development approach that emphasizes shutting the fuck up and listening to what customer is saying. And you're smiling, oh, thank you, but this is really important because I've been into so many business meetings. They were really business meetings, not IT meetings necessarily, and I saw it so many times. You sit with the customer start talking about their problems, and what do? You start creating schemas, entities, God forbid, relations, and now like even starting writing code during the meeting. If you're doing that, you are a code junkie, you are nothing else. Don't do it. Please, when you sit with the customer, listen to them, try to understand them. Listen also in the scope of not having IT processes around. Listen how the business works without IT, because probably this is why you are sitting there, to introduce your expertise into the whole process. Don't think about code, about some entities. Try to understand the process as it is. Please don't do it. So this is very, very good technique. Second technique, which is, I would say, way more difficult, and you see there are a lot of things that you will need to understand at the very beginning. I would say get into it. Definitely, all those things you need to understand in the long term. But if there are two things, I would definitely say, okay, look at DDD and start with these two things. And this goes what Lukáš was saying, is first is ubiquitous language, which means that you agree with your customer on unified vocabulary, because, okay, here you see that curing and curing has different meaning. Also, order and order can have different meaning if you are in prison or if you are Amazon. So, like, even if those work conditions are nearly the same. Anyway, agree on unified vocabulary, use it everywhere. Everywhere you code, your meeting, call, diagrams, architecture decision records, everywhere, just start using it so you all understand, and, as I said, document it. And second thing, from the DD you could do right away, without any obstacles, is, for me, thinking in events. Because when you, again, and we are going back to the shutting the fuck up and listening to customer. When you talk to customer, they never start using like, oh, when we observed the entity, this happened. No, they are thinking, speaking, explaining in events, because this is how normal world usually behaves, that if something happens, someone reacts to it, something is changed, and blah, blah, blah. So customer thinks in events, naturally, and you should do it as well. So start involving event thinking and events in your code. There's one hint, like you could, of course, if you are talking about, for example, order, you can say order upserted, order upserted, order upserted, order upserted, which is like, in theory, still you are thinking in events, but they are totally useless because there's no business intention behind. So don't use two generic names. Follow like order placed, payment process, shipment prepared, order delivered, even if I'm now using domain events from different contexts. Doesn't really matter right now. But follow the paper process as much as possible and model those, name those events around it. The name that I would like to really recommend you already was mentioned here. It's a Scott Lashin. There are many books on DDD, the big famous red book. I would really, for total beginners, really recommend this one, because not only because it's using F# as examples, of course, but it's written in really natural way and describing exactly the same thing, like someone is sitting with people who try to make paperwork into the IT, into the software, into the application, into architecture, and Scott is perfectly explaining how to do it, how to think about it, and also he's using this ubiquitous language, he's using made-up samples or made-up code samples to abstract you away from the code or programming language you already know. So this is really, really great reading, so definitely start with it. One hint for me, it's whenever you start, you always start, or I used to always start with like CRUD, which stands for create, read, update, delete, and everything was around this like sort of thinking. If I'm going back to the thinking in events, I definitely, this is a hint for me, directly start right away with CQRS, which is really great pattern, which stands for like command query resource aggregation. It's just easy, like you just split the things that are different, because views are like read-only actions. When I ask you, what's your age? You give me the answer. I'm not like changing your age by asking you. I'm not changing anything. Like, of course, in reality that I'm asking you are taking your time, so you're getting a few seconds older, but let's take this away. But this can be create views as a really views, like image, like a database views can be created independently, can be cached, can be pre-calculated, can be completely taken away. And then you have a commands, which are like business intention to do something, like I would like to place order, I would like to cancel order, I would like to send a shipment, whatever, I would like to add another item to my already prepared order. And if everything happens well, then command starts to produce events that something happened. Events, it's immutable, it's in past, it already happened, so you're just notified, but you can like observe them, you can change them, you can do whatever you like. And many times when you start with CQRS, I said, oh, you need to do the event sourcing, and you need to have more databases, so you cannot use transaction. Bullshit, you definitely can. You can, even those things can come from the one MySQL or PostgreSQL table, doesn't really matter. It doesn't on this level, doesn't really matter. For you, it's only about putting up the business intention and split the things that when I'm reading something, I'm not changing, and when I'm changing, usually it doesn't return anything else that list of events that happen when I ask to do some change. I need to warn you, start the car. There are some hot takes because I like to do it, just to like piss some people off. So, my first hot take, it's related to it. I would say never do the CRUD. I like don't do it in for simple application. Just forget it that really like you will create user or update user, update, delete user. Like no, because back to the business problem we are trying to solve, you are not doing that in a real life. You register user, you change password, you change address. So please, don't forget about CRUD, definitely on higher code level, and get used to adding business intention into your code, because then one day you will benefit from things which is like task-based UI. For example, if I want to change the password, I'm working only with the form or the UI only for changing password. I don't need to go through, all the entity and updating something, because back I'm not able to find what really was the business intention behind the change. This is totally obvious because we are having Agile Manifesto for 20 years or something like that. But what really happened is to get rid of unnecessary steps in between and back getting to the understanding the business problem is kill the messengers, get rid of all those necessary steps. Of course, sometimes probably if you are working for a big bank or you are working, I don't know, for hospital, trying to do some stuff, sometimes it's difficult to get to your end client and customer, I know. But usually, for most of the application, when you have any kind of chance to work directly with the end user or end customer, you must reduce the steps in between to get the right information to the right people. Because if I read something and I ask Lukáš to write it, he will write totally different stuff. But as I said, it's in the Agile Manifesto for 20 years. And of course, you need to pre-select right people to talk to customer. I know people who would kill the business if I will let them near customer. I have some colleagues like that, but if you pre-select correctly, it's okay. One thing, and that's my also hot take, one thing I like about GraphQL and gRPC over the rest is going to the CRUD, is going again to the business intention, is that GraphQL has a direct separation between read and write side. We have queries, we have mutations. So if you have the possibility, go over there right away. If not, you want to stay with JSON over HTTPS because it's easy to set up some kind of JSON server, no problem. But and we did it many times. But you should probably thinking about creating business-based endpoints, because if you strictly stay with what HTTP methods you have, you end up with the CRUD again, which again will get lost because you are now forced by, let's say, REST definition, you are now forced to think about entities, and we already know that entities are made up by us, not by business. One thing I would like to tell you is please do repeat yourself. Do repeat yourself until you are 100%, or as our hockey players say, 120% sure that the abstraction you are going to introduce is correct, because usually it's not. So, for example, I have really simple, I promise to bring some F# code. I have simple command, like to do MVC application, that's doing 3 things. It's adding task, it's removing task from the list, and it's mark task as a completed. And if you look at the payload that each action is holding, that I have remove task and complete task, they just holding the ID, because why not? One smart person could say, hey man, you're holding ID there, maybe this is the same payload, right? Let's put it on one, save some typing. No, because it's different action, and the thing that is holding same data now, it's first of all coincidence, and second thing, when you say, okay, I want to do different things when I'm removing task than the completing task, you go to one place, change it, and it's done. You don't need to jump all over your code base and realizing where you put ifs and stuff like that. So please, I'm not saying write total duplication, but for example, rule of 3, if you stumble upon the third time the same structure, maybe give it a second or fifth or 10th thought, if this is probably something which can be abstracted away as some kind of structure. But until then, duplicate and you're okay. Sorry to say that. And my last one is my favorite. Yeah, I think, and generally I'm thinking that OOP is the servant of complexity for one reason, and this is going back to this Gaussian distribution. I used to do OOP a lot. I've wrote so terrible code. It's because I think OOP, it's too powerful. It's too powerful for less senior people, but even for some seniors. It's too powerful because you are forced to handle the data and the behavior at the same time or even think about it. And sometimes you just need one, sometimes you need both. But what I like about functional programming is that you have a data, you have a structures, and you have a functions which are working on those data. And there's also can be some relations between functions thanks to higher order functions, stuff like that. And also data can be have some connections in between. But it's way easier. I just wanted to say this because, as I said, I like hot takes. And making something so powerful, so amazing, I love it, but so powerful, like inheritance, giving it to young people and say, come on, duck extends animal, do it. Well, it will end up in disaster. Truly, I did that many times, so I can say it. Okay, no more hot takes. I just wanted to, as I said, piss off a few people. And so, summary of all of it is that whatever you're thinking about code, architecture, whatever, you need to realize that you are here primarily to solve business problem, not to have fun while writing code. You need to listen to the customer, keep things simple, until you are really, 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 really sure that you will make some abstraction or make it more difficult, keep it simple. Thinking events, because this is how the business is happening and how it's understood behind the IT barrier. And beware of my favorite beast, premature abstraction. So don't forget about it. We are still here. Even after this talk, we are still somewhere here. And thank you very much. That's all.
Thank you, Roman, for this amazing presentation. Does somebody have questions? Yeah, okay.
Thank you. So should we use an event store?
No, you should use microservices, not at the beginning. Event store is great, but, and I am lucky, if I can say like that, to have the first-person experience with working with event-based system, and it's great, but you need to work with data changing during time. You live in whole history, which is why would you use event sourcing and event store? But on the other hand, there are so many issues around it. I'm still saying that even Greg Young is still probably working on his book versioning of event sourcing system. So not definitely at the start. I would say introduce events, but store them based on the events, what happened, just put it as an update to the table. Why not? If you don't need a history, I would rather take the same event and store it into JSON somewhere, into some, data lake, whatever, just to be sure, because I can read it later if it's properly stored. And you will see during the time if you need this kind of powerful thing, because unfortunately in IT, any power comes with responsibility, and this is big power with big responsibility. So don't start with it, but get your hands dirty, definitely try it. But I wouldn't involve it at the beginning. I did this mistake, and it was painful.
Can I ask, how would one handle PubSub? Basically just, let's say that you have something. Oh, yeah, sorry. So, my question is if we don't have an event store, how should we handle PubSub? One solution would be to just have it all in line in the code, kind of all together.
It really depends. Of course, I think you can PubSub by design. You can handle it because event store is only about storing the historical events. It doesn't really matter. When it's happened, you just need to publish it over topic, over queue. it's totally, I would say, like agnostic to how you stored the events. When you're reading back, when you are getting to the state where you want to again react on event, that's the different story. Because sometimes if you want to backtrack or go back in a point of time, then event story is great. But any kind of notifications that were outside the system or outside some boundary, it's the same. Like I would say, it's the same no matter how it's stored inside. So like you can store it, you can send it to, I don't know, RabbitMQ. It doesn't really matter in this.
Thank you.
Okay, somebody.
Thank you. Going back to your example when you're removing the task or something like this, the same structures.
Yep.
Yeah. Removing and completing tasks, and like
Yep.
I'm curious, like how would you handle that in like domain logic? I mean, like let's say for example that when we complete the tasks, we want to produce some event that like would, for example, increment some statistics and also sending the mail, hey, like this guy completed this task. And how would you model that? Like, would you directly like using the low-level entity or database entity? How would I do?
How would I model? Like, because you said when I complete the task, you want to do what? You want to calculate something or?
I want to calculate something and like send a mail.
Yeah.
Hey, the task is done.
Yeah. For sending a mail, I would probably use like outbox pattern when I would, when task is completed, inside my own logic, probably during one transaction, I change it into the database, the task is completed. Plus, I will store it into another table that I want to send email. And then I will have a different process that going over because I just want to have the transaction used for me to be sure that when something happens, I also can send the email. So I will use, for this particular task, I would use the outbox pattern. But for, again, when you get to the thinking events, you realize that there are like internal events that are happening within the system that nobody should be aware of, and they are, I totally simplified it for like 30 minutes. And then we have like domain public events that someone said, okay, this has changed. You can do like whatever you like, but we are not going to change that. Like payroll was delivered, and everyone got a payroll in their email, and you can probably react on it from different systems. So it depends, of course, if it's internal or external event. But those internal ones, keep it, use the transaction, keep it internal as much as possible. And then anything you push out, you don't care who listens. Like from your context, like do your stuff, but I don't care. So I would treat it like that.
Okay, thank you. And I have a follow-up question. How would you handle like putting the business logic and the side effect or persistent layer together, like something like a fast state pattern?
Oh, one of the like easier thing we have command handlers that's working with this type, doing like pattern matching, what really needs to be happen. And one of the dependencies of command handler is usually, let's say the database connection or database context, whatever. And inside, so I know that this one is impure because it probably needs to check the state on the database and if can I do it or not. So this is like pure data in, impure command handler, doing their own stuff with dependencies that it needs, because sometimes you can have commands that are happening on database, commands that can happen in Excel, for example. You can have like Excel command handler if you like, be my guest. And then it's the production of those events which contains the information that I want the others to know. And sometimes because the command handler has the access to the information that you, when you are sending the command, you do not, because this is working in like impure world, you can have more data into events that are coming from the commands. Typically, like probably also some errors, messages, or things what went wrong in the probably on database level. But this is how I will put it. So pure data, impure command handler, and then again pure immutable events. And again, another one because then you can plug the command handler with event handler, because this is just like binding, mapping. This is just piping together something which produce list of events, and then again, I can have multiple event handlers that are reacting on it, sending somewhere, storing. I can do it concurrently, no problem with that. Of course, it depends, but if you are staying with your, start with modularized monolith, it's pretty easy because most of the times, if something fails, it fails as a one thing and you are okay. If you go into distributed application, then we are in totally different discussion and we need to go back to what you said. We need to think twice and mark down what is important, which is can be sent later, or if I never get an email, it's okay, I still get the money. So yeah.
Thank you.
I'm just curious, when do you actively change architecture on an existing project? How bad do things have to get?
My personal opinion on this is strong that you should do it actually all the time, because either and of course depends on what degree of change are we talking about, but I would say, and this is also how we are working for years in, for example, in HR department, I say, let's do it in a way that we can always change it quickly, rather than, we think it through and then we cannot change it anymore. So I would say we are doing a lot. Those things like events, commands, of course we are adding views, changing views, but actually those essential parts like events and commands, we are not using so much, changing so much, because if we listen carefully, they are probably not changed because business changed meanwhile, but structure around, for example, if there's new feature requests coming, I would like to also have, I don't know, emails and now SMS. Yeah, we're changing things a lot, but I would say the domain, if I look at like domain and the whole IO somewhere below, then domain as the top of the structure is not changing so much.
And what about projects that haven't been involved, that you just inherit, that you start on, but someone else had different opinions on what's the correct architecture for?
That's always also my colleague struggles when they inherited project from me. So I know the pain. We all know. If the core is correct, if it's not rotten from the inside, and we had some projects which was so bad when we did the analysis and we said if we will need to change it so much anyway. So we just rewriting it, and now we are rewriting in F#, and it's fast actually. It's good, but it depends on how badly it's designed. If this is design flaw in the pure core of understanding the business, then probably it shouldn't even get to the state of someone is using it. It should be stopped during the development in Agile. After 2 weeks, you realize that this is going wrong direction, usually on demo. But if this is not terribly wrong, you just work around it and in circles and removing something. If you are still in one domain, it's okay, or in one context. Thing is, we discussed this last week with guys who are working for a bank. They have about now 25 microservices, something like that. And I asked them how often they, not splitting, that's usual, but merging together stuff. And they said this happens. They said that they realize they're kicking the same ball from two sides, so they just merge it together. So it even happens in this microservice world that it, by theory, should not happen so much that they're changing it. So I would say it's normal, but it depends how rotten it's inside. If it's not about bad domain, then I think it's okay. You can work around, definitely.
Yeah, thanks.
Okay, Jirka.
Yeah. Okay, I would like just to add a couple of points to Roman's answer. And one of them is, if you are approaching the design of the software in a way that he described, that you don't create unnecessary abstractions from the start, then you don't really change the architecture in the sense that you were pointing towards, because you are changing the software all the time, and the architecture is always changing, but in small increments, so you don't really notice it. And when there are any larger changes needed, then I think in that case F# itself will help you in a pretty big way because of its strong type system where the compiler will just scream at you until you have it right and the architecture is correct again. So I think that's one thing. And then I would also point out that on the slide that Roman shown us, even that slide is slightly over-engineered.
This one?
Yeah, this one. Because for the remove task and the complete task, you can only have the int on the remove task case itself, and you don't need the record. So,
well, that's where we would have an argument if we were working on this code base, because yes, but again, it's ready for change, because from this perspective, the command signature is still the same. It only changed the data that is holding. But I know what you mean. I had it initially like that. But from my experience, okay, this will remove like complete or remove task will remain there forever like that, definitely. But it has, on the other hand, unique style of thinking. So yeah, this is where I would not agree with you, but we are having these fights all the time, so I like it, yeah. All right, I don't want to block the other speaker because I see Dominik is falling asleep. So thanks a lot, thank you.
Okay, so let's have a 5-minute break and then the last speaker. Thank you. Hello, we are about to start, so if you can please sit down. Thank you. Okay, so I'm happy to announce Dominik Moštěk from Ataccama. He's gonna tell us about some clean coding.
Hi everyone. Tonight I would like to talk about what I call guerrilla clean coding. The subtitle of this presentation could be writing better software without making everyone hate you. And why someone would hate you for writing better software. I will repeat a Roman here with the bell curve. I have it a little bit not meme style. The reason is, if you want to do things better, you are probably on this side of the curve, which means that you are basically fighting against the mass behind you. So if you are going to outperform others, they might hate you. They might love you or hate you. So this presentation is about not being brilliant jerk. You probably know those two guys. This friendly, incompetent developer, everybody loves him. He does a lot of work, but his work sucks, basically. You hate maintaining the code he writes. Everyone hates it, but he does a lot of work because he's friend of everyone. So he gets to the greenfield projects, greenfield repositories as first one. And then there is a brilliant jerk. He has brilliant ideas. He's a clean coder. He knows TDD. He knows everything. But everyone hates him. Nobody invites him to the meetings. No one wants to pair program with him. So his genius mind is basically useless. So about me, my name is Dominik Moštěk. I'm around 15 years in professional software development. I went through the big corporations, startup, and now I'm in Ataccama, no longer as a software developer, now as an engineering manager. During my career, I developed mostly in JVM-based languages and the ecosystem around it. I love OOP. And at the same time, I also love functional programming. I know it's weird, but there is a huge symbiosis. And I'm always unhappy with the code base, and that's my code for being a brilliant jerk. So that's my today's confession is I was the brilliant jerk for large part of my career. So today I would like to share some tips for you how to avoid it. It's a mix of code and non-code tips in random order. But before I get to that, I will repeat what Lukáš was starting with, and that's the basic question. What is the architecture? I love the definition by Martin Fowler from his article, Who Needs an Architect? And it's real simple. Architecture is about the important stuff. The article is really great, and Martin Fowler uncovers big details about what the important stuff is, whatever that is. It sounds stupid, but there is a huge wisdom to it, and that's it matters. Because what's important? When you say architecture, the first thing that comes to mind of most people is some UML diagrams or any other type of diagram. Is that important? If you are working for a company that provides for the government, then that's the important part and the invoice. It might be. I'm not saying that it's not important. Mostly it's not. Is your AWS or any other cloud architecture important? Might be. If you are about infrastructure costs and so on, that's the important stuff. Is your tech stack, the frameworks, the applications and so on, or the databases, the important stuff? Might be, if you want to attend technical conferences and look cool. Then this is the important stuff, and this is what your architecture define. All of the stuff I just showed, it's up to debate if it is important or not. What I think is not up to debate is the maintainability of software. That's important all the time, because as Lukáš said, this is the growth of the software. That's the core why software is software, because it's easy to maintain as opposed to hardware. I usually sum this up as solid principles. So for me, solid principles is the code name for maintainability. I'm not going to present solid. That's for another presentation. I just wanted to remind that the flexibility, the maintainability of the software, for me, that's the architecture. But why most of the projects I have been working on or you have been working on sucks? Their architecture sucks. It has much to do with the bell curve and the friendly incompetent person I have shown in earlier slides. And there is a, let's say, science behind it. This is a tech debt I borrowed this quadrant from Uncle Bob. He assigns the tech debt into four categories. One is deliberate, like you did it on purpose. One is inadvertent, it means like made by mistake. And second dimension is reckless, meaning like we did it because we don't know. And prudent is that it was, again, the result of some decision. And most of the time, our projects are in those two quadrants. Like we don't have time for design because someone says, it's not like universal truth. Someone is saying that, so everyone is following that. Usually there is time for design because the time for the construction of software is a sum of the development and the maintenance. If we take away the time from the development, we add it to the maintenance, basically. So that's one reason why it sucks. The other is pure incompetence by the friendly, incompetent developer, thinking that he knows everything, but he basically don't know anything. So how to do clean code and good architecture without being noticed? Disclaimer, don't do anything without your team knowing. I'm exaggerating here, but sometimes you want to do stuff your way, to do better software, to have a clean code, better product at the end. Sometimes you need to go around someone or the code base. So here are my tips. First, the most important one, be the change you wish to see in the world. Talk is cheap, do the work. So if you stand for it, practice it every day, practice it on your code base, don't talk about it, do it. Because that's the evidence you will provide to your team, to your colleagues. And you might convince them that your way is the best way, but you need to show it, not talk about it, as I'm doing right now. Practice TDD, write unit tests, write understandable code, maintainable code, take ownership of the code you will produce, then just code it and throw it over the fence. And if the way how you think you should write the software turns out to be wrong, just admit it. Don't prolong the pain. Just admit it, rewrite it, take the ownership of the code you just wrote and rewrite it. Admit that it was a wrong way. Stay small, don't do big bangs. Refactor small chunks of code. It has very practical reasons. Small chunks of code you can easily reason about. So when you are explaining to your colleague, it's easier to convince him that your way is better because you can explain the benefits. On huge on huge pull requests, it's impossible almost. And one really practical thing, if you are going to do big bangs, you will maintain it. So you will become silo maintaining most of the code base because your colleagues would not want to touch your code because they are not familiar with it. It's your code, so be aware of that. Don't complicate others' life. Every change you do to the code base, make it backward compatible. Make it small and backward compatible. For me, it's a professional code of conduct. Always do things backward compatible. And it applies for API, for binary compatibility, for everything. Leave a trace of documentation, a lot of documentation. And I don't mean this documentation. This is average documentation in the code I worked with. This is the documentation I'm talking about. This is a snippet from Spring framework, which is one of the best documented piece of code out there. So clearly states your intents, the context, provide examples, provide links, as much information as possible. In order to write better software, you need to extend your horizons, basically. As developers, we do it by learning other languages. And by other languages, I mean really other languages, not Kotlin if you are a Java developer. It's the same language with different syntax. And my advice, which Roman will really love, is just learn functional programming, for the love of the God. Since we are not free to choose the language we are working with, like it's in the project for some time, we still can write functional code. And here I'm just I will refer you to my other presentation. from Geekon, which is called From Objects to Functions, which is about writing functional code in your non-functional language, in this case, Java. So it can be done. Use facade and proxies and other patterns, again, to fly under the radar. Just stick to the norms, to the packages, to the interfaces and everything that's set up in the project, and do whatever you want inside those facades and proxies which adheres to your conventions. And a quick example, it's not important what's inside. What is important that by the first look you can see that this is a really weird Java code. It's not usual Java code. The important is that it's different from the average, but it adheres to some convention, to some interface which wasn't created by me. I just did my kind of coding inside a known interface for others. So don't try to break everything, break interfaces and so on. Just use the interfaces even if you don't like them, but keep your style inside of those proxies and facades. What I really like is to use anti-corruption layer approach, which is basically the same as facade, you can say. And that's by using features of your language. In Java, it can be inner classes, some less known interfaces from SDK. In older versions of Java, it was anonymous classes. Now it's lambdas. In Kotlin has a great support for writing DSL. So explore that, and by using the DSL support, you can make the adoption of your clean code easier for others, because it has a really nice API. As I said, become masters of solid principles, because that's a core of writing good software. And I mean, if applied on all levels, on levels of infrastructure, separation of the services into microservices, on level of API, on level of code, on every level it makes sense. And again, I'm going to refer to another talk I had on this exact place, like 2 years ago, on Lambda meetup, about solid, again, being functional. You can see that I'm in love with functional programming. One big tip, make everything API first, and make front-end developers your friends. They love good API, and if you start with API, it will drive your design for the better. As Roman said, he doesn't like the rest and so on, because it forces you into the CRUD style of writing code. If you avoid this CRUD style, and most front-end developers don't like it, so they will force you into non-CRUD style, more event-based style of API. It will influence your code. And if you get front-end developers on your side, you have half of the work done. Be consistent. Choose something you will be different in, the style of the programming, the paradigm, whatever, but be consistent. Don't hop on the hype trains, because now, I don't know, some hooks or coroutines or something is cool nowadays. Just pick something that you are really sure that is the right way, and stick to it. And have a good backlog of arguments why it is better. Not what, but why. So you can explain to your colleagues. The usual argument is solid, of course. Because we are coders, but we are humans, and as humans we are social animals. And programming is a team sport. You need others to make things happen. You need your team. So understand your team to know what are their motivations behind their approach to writing the code they feel is better. I really have to recommend this book, Driving Technical Change, why people on your team don't act on good ideas and how to convince them they should. It's a really thin book. It has like, I don't know, 50, 60 pages. But so you can go through it over the weekend. And it describes 10 personas, type of people on your team. And I'm sure while reading it, you will reckon some of your colleagues. And it describes the motivations they have behind their approach for coding and how to interact with them, how to approach with, for the arguments with them. It's just a code, so don't be, is it recorded? No, doesn't matter. Don't be a dick. It's just a code. Don't put your ego into it. It doesn't matter. You should seek cooperation, not confrontation. And my last tip, give up sometimes. As I said, it's just a code. And if you push too hard, you would create resistance, not a cooperation. You should solve problems. The code is just a way how to solve them. So sometimes going a few steps back is better than going your way, because aligned team is always better than having a clean or better code. And that's it. I hope I put a seed in somewhere, and it will sometimes result in this beautiful flower, even through the resistance of the concrete. So thank you.
Thank you so much. I'd like to thank you because I thought I'm the only one who is always, bad. I feel bad about like the whole project, the whole code, and I like to find somebody who is also the same guy and who's always unacceptable for the PRs and always complaining about stuff. So thank you. I also like to mention the cool book called Clean Code, which is really fun thing. So I recommend to everybody to read that, because in that book there's all the solid principles written in like 300 pages, and it's really interesting. So if you want to dig into that more, that's great. And thanks for like not being jerk, because I'm always telling the people, to my mentees, when I'm really talking about the architecture about like 2 hours and they trying to fall asleep, and so I'm always finishing that like, okay, let's wrap it up. Like, don't be a jerk. That's all you need to do. So like, think about your work and it's gonna be fine. So yeah, thank you so much. Do you have some questions? Yeah.
So thanks for the talk. It was great listen to those opinions, and just like to add that as an opposing kind of opinion on the solid principles, there's a guy, Dan North, he created his like own kind of term, Cupid, which is really, and he created because sometimes the solid can be kind of vague to interpret. So just look it up, Dan North, Cupid principles. And then for the rest of you mentioned, there are two terms in the, like, I've came across to. One is like broken window theory, which is created by Dr. Zimbardo, and it was translated to psychologist Dr. Zimbardo. It's translated to the software development as well. And basically it's saying like, if you go to the place which is full of shit, there is likely you just have intention to leave a shit, no better place. And I've seen it all over the place in the developers. And And the second term is like Boy Scout rule, kind of. You go to place, you see shit, you try to clean it. So those kind of goes to opposing together. And my question would be like, if you, during the code review, like being like inherited code base, like from another agency or whatever, and your colleague is like going to the place which is not really nice and just does his work, maybe leaves a little bit more shit because it's shit place. And if your comment is like, hey, you could do a little bit cleanup. It's small, minor changes, and we can do this by this iteration steps, better place. Am I a jerk?
Yeah. No, of course. If your comment is saying, "Hey, Charles, your code is shit. You should feel bad," then you are a jerk. Always be polite and accept that you are not going to force your way all the time. If you are alone, in this opinion, then yeah, you have to live with it. If you on lunch with your team discover that others feel the same way about Charles, I think you should talk to your manager. That's the only way, because the team spirit, the team alignment is really the force pushing the team forward, I think. And sometimes it means saying goodbye to someone if he's not going the same way, or like creating bad mood in the team.
Okay, thank you.
And I wonder if there is an opposite of broken window theory, because I know it. If there is like a clean window theory, like that the clean code attracts more clean code.
I think it truly relates, because the Dr. Zimbardo backs this one with like true experiment by leaving the car in like nice car in like shitty neighborhood. The car was destroyed like swiftly. Then I might be missing some parts. Then he left car in nice neighborhood, was there for like, I don't know, weeks, days. Then he went, smashed the car, and the car after a few hours or days was smashed even more. So I would say this is the same thing,
I hope that it works like that, that clean code attracts more clean code, and nice cars attract more nice cars.
I believe so as well.
So thank you. Have a nice evening. Or are there any other questions, Lukáš? No? Okay.
Okay, so thank you all for coming here. So here's a beer, and let's continue with like free talk and networking. Thank you so much. Oh, sorry, and there's the quiz. So like there are QR codes. We have quiz prepared for you. So there are like all the presenters gave out some questions, and if you fill it up, you will win some prizes. So you can feel free to scan it, and yeah, you can fill the quiz. Thanks.